My name is Isaac Montoya, and I am the Director of Marketing here at Upside Technologies. I would like to thank you all for joining us here today for week 3 of our 7th annual Airflow Management Awareness Month. For those of you who don't know, we started Airflow Management Awareness Month back in 2015 with the intention to not only raise awareness around airflow management, but also around cooling optimization, thermal efficiency, and overall data center best practices. We've received great support from the industry, and we are happy to be back for another year. I'll be joined here shortly by Mark Acton, Independent Consultant and Non-Executive Director at EchoSense, who will be headlining today's webinar on data center risk management, as well as Lars Strong, Senior Engineer and Company Science Officer here at Upside Technologies, who will give a brief introduction for today's presentation. Before I pass it off, I would like to go over a couple quick housekeeping items. Everybody will be muted throughout the duration of the webinar, but we do encourage you to ask as many questions as you would like, and you could do so using the Q&A module located in your Zoom dashboard. If you happen to have any technical difficulties, please feel free to shoot me a message in the chat module, and I will try to help resolve those as quickly as possible. As I mentioned, this is week 3 of our annual Airflow Management Awareness Month. In week 1, we were joined by Lars Strong, who gave a very informative presentation on data center containment best practices and what to consider to maximize ROI. Last week, Lars was joined by Tracy Collins, Vice President of Sales for the Americas at EchoSense, who discussed how artificial intelligence and machine learning can optimize data center performance. If you happen to miss either of those presentations, please feel free to shoot me a message in the chat, and I can provide you with a link to where you can watch those on demand. Next week, we'll be joined by Bill Clayman, Executive Vice President of Digital Solutions at Switch, who will discuss how modernization and new digital demands have impacted and changed the data center. If you haven't already registered for that session, we'll be providing a link later in the webinar for you to do so if you like. Now, without further ado, I'll pass it off to Lars to get us started.
Thank you very much, Isaac. It's really a pleasure to be here with Mark today. Just want to share a few things about Mark. We're really excited to have him here and let you know that Mark has been a regular contributor to the Upside Technologies blog, and he's spoken on a lot of different topics there: emerging trends, data center risks, metrics and standards, and efficiency. So look for his topics there in our extensive list of blogs. Mark has over 25 years of experience in the data center industry and has been a specialist in the field of data center operations for over 20 years, concentrating on the delivery of business critical services from highly reliable, world-class data centers. He's provided consultancy and technical advice, as well as senior management roles for service delivery in both strategic and operational management at organizations like Intel, Dell, the Uptime Institute, and CBRE. Mark has extensive international experience and solid technical skills covering data center facilities, design, and IT and facilities operational management, obviously very closely related to risk management. Mark is also a regular public speaker, conference host, and he is currently acting as a consultant and non-executive director for leading data center operators and solutions developers, as well as being involved in international data center standards development. So really a breadth of knowledge covering a lot of very important topics related to this one. We all know that data centers have become the backbone of our digital infrastructure, and our reliance on them has been increasing. And recent data is showing that the failure rates are actually increasing, and the length of the outages is increasing. So this topic is really important, and Mark's going to discuss this today and talk about both the human factors and the physical, and provide some guidance on how to mitigate those risks to ensure uptime and maximize resiliency. It's not a simple topic, but I believe Mark is going to really help shed some light on how to get started approaching this at your facility. So with that, I'll hand it off to you, Mark.
Thank you, Lars, and thanks for the introduction, Isaac, as well. I'm just, I believe I have control. Yep, I do. I think we have, yeah, we have control. So again, thanks very much, Lars. Thanks very much, Isaac, for the introduction. I'm not sure I deserve all the praise, but thank you very much anyway. And thank you everybody out there for joining. Again, today, as Lars has suggested, I'd like to run through some of the risks that we actually face in the data center sector. I think, there are obvious risks out there, but I think there are also quite a few risks that maybe not quite as obvious to all of us as some of the the things that we deal with every day, and some of those gotchas that are out there really are potentially quite damaging and things that we really need to be dealing with. Then I'd like to, in the second part of the presentation, look at some of the ways that we can mitigate those risks, particularly on the operations side, how we deal with those risks. It's one thing to recognize the risks clearly, but it's something else entirely to find ways to actually mitigate those risks and deal with them. And then we will have about 10 minutes or so at the end for questions. So if you do have questions, as Isaac's already said, please put them through the Q&A part of the platform. We'll try and answer questions at the end as we go along. So by all means, queue them up, and we'll see what we can do with them towards the end. See how much time we have. With that said, let's move on through the agenda. Okay. Sorry, just apologies for that. It's responding slightly slowly to me, but we are getting there. So the first section of this presentation is going to be understanding the risks that we actually face. And I'm going to try and give you maybe an understanding beyond the obvious, I think is my intention here, to some of the things that we may not consider every day when we're doing our sort of day jobs. There's quite a lot out there that can catch us out that we may or may not be aware of. So again, I'm going to try and highlight that to a degree. So firstly, let's try and understand why risks are important. So firstly, what's a data center? It's a building or an area of a building whose entire purpose in life is to provide secure, highly available and reliable IT services. We sometimes forget that. We sometimes forget that the purpose of a data center is not just to provide power and cooling. It's actually to support the IT services that sit within that data center. So with that said, why is it so difficult? Well, IT equipment is actually a lot more sensitive than humans. With humans, they'll tolerate a fair degree of discomfort even when the cooling's not quite right. We've got a fairly wide tolerance in terms of temperature and humidity requirements. We don't mind if the power goes out too much. It may stop us doing our job temporarily, but it's not going to kill us. But with IT equipment, it's very, very different. They require very stable power. Remember that a UPS both conditions power as well as providing battery autonomy. It's not just there to keep the power on, it's actually there to make sure the power is right. There are lots of warranties, IT equipment warranties based on very narrow environmental operating envelopes. ASHRAE is obviously the reference behind that. And we've obviously got huge expectations from businesses to keep those applications up, available, and running. In many cases, if applications in data centers were to fail, there's a strong chance that the business itself would fail. And we have a very, very multidisciplined environment. We have different disciplines in the data center. We tend to operate in a very siloed manner. We have the IT guys. Even the IT guys tend to be split between themselves a little bit. The network guys may or may not talk to the storage guys, and the hardware guys may not talk to the software guys. So we've got that element going on. And then we've got the facility side of things where, it's quite possible that, the two sides of the house, the facilities and the IT side of the house, are talking very, very different languages and actually may not communicate at all. The presentation I've got is very content rich, so I'm not going to read off everything. I'm not going to go through every line in this. It would take far too long. I'm assuming that everyone in the call can read a lot of this for themselves, but I'm just going to sort of set the tone on each slide rather than reading through everything. But the one thing I would say on this is that the requirement for 24 by 365 operation actually makes things very difficult. if you think of the analogy with an aircraft, with an aircraft will be run for several hours, it may be hundreds of hours, whatever. But then at some point, that aircraft is taken out of service, it's put into a hangar, it's effectively taken apart, it's checked over, it's to some degree rebuilt, and then it's deemed to be fit for purpose. Everything on that aircraft is checked for wear and tear, and then it's put back into service. And as a result, aircraft are incredibly reliable and incredibly safe. In the data center world, we don't really get that luxury. We don't really have the opportunity to necessarily turn things off. We have to keep things going. So the analogy I use is when we're trying to sort of operate and maintain data centers, it's almost like trying to replace the engine on an aircraft when it's actually in the air. So it's not easy to do, not easy to do at all. And moving on to the next slide. Another reason that data centers are so challenging is, we all want to be cost efficient. We all want to reduce the cost both to our business, we want to reduce the overheads, but also we want to reduce the cost to customers. Obviously, we're in a competitive environment, but the more costs we take out, the more we value engineer, the more we introduce risk. It's very easy to have a data center with low levels of resilience. And of course, that's going to cost you less money to build because there's going to be less capital plant installed. So that's really quite easy. The trouble is, as you do that, you tend to introduce more risk. So there's a balance. There's a balance between cost and risk. And that makes life very difficult. It makes life very challenging. Value engineering can introduce a great deal of risk. So that's something we have to be very, very aware of. And many data centers, particularly public sector, I'm not sure about the US, but certainly in the UK and Europe, the public sector, some of our more critical data centers really don't have the budget to maintain things properly. So, we face significant risk in many cases. Some other common issues that introduce risk: a lack of a complete and accurate inventory. How many data centers have a really good understanding of the assets they contain? Particularly the IT assets. Tends to be much better on the facilities management side because we tend to have scheduled maintenance regimes that deal with those facilities assets, the power and the cooling side of things. But on the IT side and the network side, we tend to be pretty poor at keeping records. And of course, if we don't know what's in our data center, it's very, very difficult to actually make sure we're looking after it properly and that it's being managed correctly. We don't necessarily have good understandings of our capacity requirements. As I said earlier, data centers are built purely to host IT equipment, and yet in some cases we don't plan those deployments. We don't plan the capacity requirements. We also have very misaligned, in some cases, facilities and IT objectives. Again, the objective set are potentially very, very different, and the communication between those disciplines is actually very poor in many cases. We also may find that in some enterprises, particularly, critical resources aren't ring-fenced. So I've seen situations where budgets have been pulled from the critical side of the business into the less critical side of the business, putting the critical side at risk, and the business not understanding that the risk they've actually introduced it by doing that. They've prevented the data center from being maintained, or even life cycle replacements, necessary life cycle replacements being put back beyond what would be considered reasonable because budgets and resources have been pulled away from those critical areas. And that has, in some really quite evident cases, introduced massive risk and actually failure, genuine failure. The bottom one's an interesting one. One of the reasons that people often don't do things in data centers is they're so afraid of disrupting operations. So they don't do maintenance, they don't test the generators, they don't do all the things that should be done because they're actually afraid of the potential disruption to service. You can't operate that way. You cannot work on the basis that things are going to go wrong. You have to prevent things from going wrong, and make sure that you are doing the right things by way of maintenance or life cycle replacement, etc. That's a common one, and I think you'll frequently hear stories of people being afraid or not allowed to test the generators because of potential disruption, which is clearly nonsense. If you're not going to test something and you don't believe it's going to work, then how can you possibly rely on it? There are other things that are probably less obvious, and many of those risks really are sort of somewhat hidden. one of the biggest risks I see is just the risk of based on false assumption. People tend to assume things. People might have heard at some point in the dim and distant past that they have a tier 3 data center. They may not know what that means. It may not be something that is really strictly understood, but they've heard it somewhere. They've been told it by people who probably don't really understand it themselves. And on that basis, they have made a whole bunch of assumptions. And we'll probably go into some of those assumptions in more detail later. But it is fairly common for people to believe, certainly on the business side of data center operations and in both enterprises and co-location, that there is more protection available than really exists. And that moves on to the second point, hidden infrastructure risks inherent in the site. That basically is around design. The site has been designed to do a certain job. It may be that there's a flaw in the design, but it may actually be the design is perfectly fit for purpose as intended, but it may not necessarily address the risks that a business now face because those business criteria and objectives have changed. Again, it's all about poorly informed messages. Then we have the reliance based purely on infrastructure. Will infrastructure get you out of jail? Well, maybe it will do sometimes, but it's far better to have an operational team, an operational understanding that will A, anticipate risks, and B, be able to circumvent anything that does go wrong. I've seen some very, very weak data centers in terms of installed infrastructure that have literally been kept going based on absolute dedication and training and experience of the operational teams. They are, the operational teams can, I think, make up for a great deal of shortfall in the infrastructure, but it doesn't work the other way around. And then I think there's the protection or perceived protection based on contract or SLA. And again, I'm going to go into this in a bit more detail in the rest of the presentation. But I think there's a belief that a contract or SLA will protect you. It won't. It really won't. I mean, if you lose the data center operation, again, there's a risk of the business going down. So no contract or SLA is really going to protect you against that. There are very few contracts or SLAs that protect against consequential loss anyway. There might be penalties associated with contract or SLA, but consequential loss tends not to be included. And that's a pretty big one, actually. I think a lot of people feel that they're protected to a far greater extent by the contract than they really are. And on that point, I'd say that an SLA is pretty pointless if the underlying infrastructure is inadequate. So, if you're signing 100% SLA, it's not going to protect you if the site is not capable of supporting 100% availability. It's a kind of a meaningless SLA. Yes, there might be some penalty involved in that, but again, the penalty is not really ever going to cover the real problems, the real losses, the real negative PR and the negative customer responses to a long-term failure, for instance. And I think when we come to data centers, particularly if we consider data centers as being the building rather than the IT infrastructure, it's fairly common, I think, not to take into account the IT infrastructure and the capabilities of that infrastructure, which I think should be factored in when you're thinking about what is appropriate from a building perspective. The nines. So we commonly use the nines, and we commonly use the reference to percentage uptime. But we've got to remember that the nines are just a statistical tool that really is generally based on mean time between failure, MTBF figures. They don't necessarily take into account operational practices. So, it is, dare I say, somewhat theoretical. Also, if you think about 6 nines availability, that's 99.9999% uptime, that still allows for 32 seconds a year service outage. So that could be a single 32-second period, or it could be 32 1-second outages, or 64 half-second outages, each of which is actually going to take out the entire IT load if that outage is on the electrical side. So, the whole idea that we have, a 6 nines SLA or something of that nature is kind of nonsensical unless we actually define what that really means. Is it power? Is it cooling? is it network? It's all a bit meaningless. So you'll hear a lot of people bandy around the terms of 5 nines, 6 nines, or whatever. But I think unless it's actually explicitly defined, it's a absolutely meaningless term. It doesn't really mean anything. And again, as I said here, anything more than a 20 millisecond outage is going to take out pretty much the entire IT layer, certainly 25 millisecond outage. So it's a little bit meaningless, and yet we do in the industry continue to talk about percentage uptimes in terms of nines without really actually understanding what it means. And hopefully this explains to some degree why we shouldn't do it. It also explains why the Uptime Institute have dropped percentage uptime, and that was some time ago. Also, we tend to use the term availability and reliability somewhat synonymously. They're actually not the same thing. Reliability is the probability of a system operating failure free over a period of time. Availability is the probability that at some point, well, it's the probability of a system being operational throughout a period of time. So availability and reliability are related, but they are distinct and they are often confused. And so I think when we're talking about data centers, I think we really need to understand what we are talking about. And generally speaking, we're talking about service availability, or we should be talking about service availability rather than just reliability. And again, I think it's worth being aware those terms shouldn't really be used interchangeably because they're not. The rest of this you can actually read yourselves. This deck will be available, by the way. Again, another probably a more detailed definition of availability and reliability. So availability in its very simplest form is uptime divided by uptime plus downtime. How long is a system up? And it's always expressed as a percentage, as again, and in terms of mean time between failures and mean time to recovery. So MTBF is mean time between failure, and that's typically something that's determined using individual systems components and working out really from a manufacturing perspective what their likely lifetime is, and therefore when they're likely to fail. And then MTTR is the mean time to recover, and that's typically talking about a service rather than a system. So, again, something to consider when we're talking about data centers in terms of reliability and availability. Downtime, we've talked about in terms of percentage, but again, let's be very, very careful when we use percentages. What are we actually talking about? Are we talking about power? Are we talking about cooling? Are we talking about network? Are we talking about IT service availability? What are we actually talking about here? And without that definition, the term is pretty meaningless. Hidden infrastructure risks. Well, again, as I mentioned earlier, and this is very much sort of the reference to uptime tiers here. A lot of people believe, for instance, that tier 3, it gives a certain level of reliability, resilience, and that's really not true. Tier 3, firstly, isn't fault tolerant. It doesn't protect against all faults. And secondly, tier 3, as defined by the Uptime Institute, really talks about the ability for maintenance. It talks about concurrent maintainability. So the idea that tier 3 gives you some level of protection, it may, it can do, and it clearly will do, but the real intent is to talk about your ability to maintain it and therefore to keep the systems reliable. It doesn't necessarily mean that they will be reliable in the event of a failure. So really, in terms of the way, again, the Uptime Institute defines things, it's only tier 4 that offers you fault tolerance, i.e. protection against unplanned events. Tier 3 gives you protection against planned maintenance events, but again, they're planned, they're maintenance events, they are predictable. Only tier 4 gives you protection against unplanned events in terms of uptime definitions. Now, beyond uptime, there are other schemes that reference levels or classes. Uptime are not the only game in town in that respect, but a lot of us reference tiers. A lot of us believe we understand tiers, and I think one of the things that I see quite often is people using the uptime tiers incorrectly, and again, believing that they've got some level of protection, some level resilience that actually they don't have. They don't necessarily they don't necessarily have as a result of the infrastructure they're dependent on. I had a conversation with a bank at one point who had what I would call genuine tier 3 sites, and they believe they had fault tolerance protection against unplanned incidents. They didn't, and they were extremely concerned when they found out the truth, as you can probably imagine. I think the other thing in reference to the tiers, it's useful to know is, what the tiers themselves are not necessarily ambitions. A lot of people talk of them that way. We need a tier 3, we need a tier 4. Well, the question I would always ask is why? Why do you need that? If you don't need 24 by 365 operation, then you really don't need a tier 3 or certainly tier 4 data center. You can probably get away with tier 2 or tier 1 if you can plan to have periods when the data center does not need to be available. Maybe the weekend, maybe the evening, whatever. If your business doesn't require that 24 by 365, then you can get away with something that is a lot cheaper to build, a lot cheaper to manage, but will still potentially satisfy the business requirements. So I think, as a consultant, one thing I always say is, let's don't look at the technology solution first, don't look at the engineering first, look at what the business actually needs and requires, and then base the solution around that. It's not necessarily something that every business needs in every case, to go straight to a tier 4. However much you might like the idea, it doesn't necessarily suit the business purpose, and it certainly doesn't. Some of the money that might be spent building or operating that may be completely wasted. So again, worth considering. Most importantly, the business objectives. What are you actually trying to achieve, rather than just what might be considered the best engineering solution. The best engineering solution is the one that's actually most cost effective for a particular purpose. I won't go through these in detail because, again, you can read them for yourselves. But I think what I'm trying to say with this slide is, consider what you need, consider what's appropriate for the business, and then work with that rather than just having something in mind as an end solution without considering the requirements first. So, moving on to the IT reliability and infrastructure reliability. If you've got IT infrastructure, again, going back to the point that a data center is really just there to support the IT infrastructure and IT services. If you've got true active-active mirroring or synchronous replication between sites, then actually you can reduce the amount of equipment, the level of resilience that you and redundancy that you have in your data center. So, again, this goes back to the business use case, the business intent. If you've got IT infrastructure that can tolerate failure or that can be taken down, you can move the workload to another location, then actually you can reduce the cost on your building infrastructure or your buildings. The only caveat to that is, has that IT infrastructure actually been tested? So I've, been to a number of customers who say, yes, we've got full synchronous replication, or we've got active mirroring, and that's all well and good. But if you ask them the last time they tested it, if you ask them the last time it actually tested in anger by pulling the plug, as you would in a typical data center black building test, then they really kind of look a little bit hesitant, look a little bit vague, and say that they need 6 months to plan it and all the rest of it. So while the IT guys might say they have something like that, I think there's also an area of caution, asking whether that is truly the case, whether they can truly rely on their systems, and again, how frequently they've been tested. On the building side, if we're doing the right job, we are routinely testing the fact the building can take load should the utility fail. We're routinely testing generator startup times, UPS battery autonomy, etc., etc. We test that. We know how it should work. We test the fact that it does work, and we do that on a regular basis. That is good practice. On the IT side, I don't think it's always quite so. The testing is quite so rigorous or dedicated. So while I say that we can, in theory, reduce dependence on the building, I do think that we have to be careful that we actually do fully understand what the IT guys are actually doing. some of those claims really can't always be substantiated. The other area I think is worth thinking about is as we move to the cloud increasingly, we are effectively separating the logical layer, the application layer, further and further away from the physical layer. And when it comes to the IT side, and I think this is being borne out in some of the outages that we're starting to see more often, it are the contracts that are being signed by the, let's say, the cloud providers or the MSPs that offer cloud type services, are they actually aligned with the infrastructure underlying those services, the building itself, the power and cooling infrastructure? Can it actually support some of those SLAs that are being signed? And I think increasingly not. I think increasingly the case is that the underlying infrastructure is not capable of supporting some of the contracts that are being signed, because that separation exists, and the cloud customers do not have the experience or visibility of the underlying infrastructure to be able to make informed decisions about whether it is appropriate or not. So what can go wrong? There's internal local failure, common cause effect, something that goes across the entire system. So that could be faults in control logic or software. There's obviously got the manual natural disasters, which tend to be very, very highly severe, but fortunately don't happen too often. But the reality is human error is the most common failure, or the most common cause for failure. Often less severe than natural disaster, whatever, but nonetheless, it really is about making sure that humans don't make mistakes. And there's all sorts of areas we'll go into beyond that. But I think one of the biggest risks that we face, ironically, is humans in data centers. Now, those risks might be introduced at design stage, they might be introduced at equipment manufacturing stage, they might be introduced at the operational stage, but again, they're all potentially human issues. All of the risks that we've highlighted above should be addressed, but I think the one that we can really fundamentally make a difference on is the human error side. That, again, probably the biggest risk, and it does apply to all aspects of the data center discipline: the facilities, the IT, the security. There are human errors potentially taking place in all those areas. So again, one of the things I talked about earlier is the fact that we tend to rely very heavily on installed infrastructure rather than just the way that we manage that infrastructure. The Uptime Institute, over a number of years, have actually shown that, demonstrated that human error is the most common cause, which backs up other studies. It's not just the Uptime Institute that would say this. There are plenty of other studies that say exactly the same thing. But because it's human error, they are, in theory at least, avoidable if we do the right things. And it's interesting that, from a very recent survey, 2022 survey conducted by Uptime, that they found that the procedural faults cause the most human errors, i.e. people not doing the right things. They're not following the instructions, or the instructions themselves may be wrong in some cases, but nonetheless, it's people not doing things in the right way. And again, beyond that, Uptime estimates that around 2/3 of all outages are human error related. And an important point here, I think that human errors are not just individual human errors. They're not just people that do something stupid or something wrong, or don't have training or experience. It actually goes beyond that. A lot of the errors we see could be institutional. They haven't trained their people, they haven't got the right procedures in place, or they haven't changed the procedures, or they don't have the experience to check them. So, it's not just individual error, it can be institutional error as well. There's a fascinating piece of work done by a guy called Jerry Williams, a UK professor, who came up with something called the HEART methodology. And this was actually in response to questions in the nuclear industry about how we manage nuclear installations. And he came up with a stat, and this was based on research, that there's something like a 50-50 chance of doing something wrong if we're doing an unfamiliar task at speed and under pressure. So, I think we've all experience being pushed to do something and making a problem. If we're unfamiliar with it, we're bound to get things wrong, and the pressure, obviously. So we're all familiar with that, and so it's not surprising. But I think it's an interesting stat. So if we aren't training people, if they're not familiar with what they're doing, if we are forcing them to do things under pressure and at speed, then there's a really significant chance they're going to get it wrong. And so let's not be doing that. But then on the other side of that, on the flip side, if we do train people, if they are well motivated, they're well trained, they're experienced, then that drops down to 0.04% from the 50-50. And the decimal point is in the right place there. So this just shows the benefit of training and experience and having motivation and not putting people under pressure to do the job they should be doing. Again, a fascinating study, and I think it backs up a lot of what the research that Uptime and others have done. We talked about contract and SLA. I think we often in the industry sign up to contracts that really can't be properly supported. The SLA, the 100% SLA is pointless if the infrastructure underneath it can't support it. And even if it can, there are plenty of organizations that accept the fact that they can't really support 100% SLA and just merely accrue for failure. They know the penalty is going to come at some stage, and they make sure they've got enough money to cover it. So it's no protection whatsoever. And it's certainly true that the financial penalties are never really going to cover the reputational damage, and will only rarely cover lost revenue. So the idea that an SLA is going to protect you is kind of nonsensical, really. It might offer some degree of comfort, and it might keep the lawyers happy, but beyond that, from an operational perspective, it's not really, arguably not really a great deal of use. And there are plenty of examples for this. That bottom line. Some of you may not be familiar with the EU Code of Conduct, but it clearly states that they should be operating within, boundaries that go out absolutely sort of to the top end of ASHRAE recommended, and yet they are, asking for sort of supply temperatures or whatever that really are contravening the very document that they're referencing that they say they want the supplier to adhere to. So really, really poor quality tendering and understanding of the sector. So then, we just say, fine, you don't put it in a data center, you just move it to the cloud. Well, firstly, the cloud is just ultimately someone else's data center. You're just moving the problem from one point to another. It's not really helping. And again, I think that one of the increasing issues that we're seeing in the industry is that the cloud SLAs that are being offered by MSPs, particularly, are not in line with the capabilities of the infrastructure on which they depend. So people are signing SLAs based on infrastructure that really ultimately cannot support those SLAs. So that disconnect, I think, is becoming an increasing issue. And we are, I think, in the industry seeing more and more issues around that disconnect. Interestingly, again, from the Uptime Institute survey this year, one of the key findings was that something like third-party providers provide something like 70% of outages. So if your SLAs and your contracts, your support contracts with your suppliers aren't actually back-to-back, if they're not actually aligned, then there's a mismatch. There's going to be a hole somewhere. And this is increasingly frequently the case. The SLAs down the chain, starting at the top with your cloud providers, the application layer, the service layer, through down to the basic infrastructure layer. If those contracts and SLAs aren't aligned, then again, you've got a massive problem potentially. Then finally, onto the energy efficiency and regulatory risk. We're all over energy efficiency. We're all over sustainability. We recognise that this is something we should be doing better, but we're all aware of that. I think the industry is very much signed up to this. But one word of warning. I think that what we shouldn't be doing is moving down the energy efficiency route and the sustainability route if it's going to introduce risks. So as one of the things we said earlier, UPSs are designed to both provide battery autonomy and also condition the power. If we go for a UPS that might be considered more eco-efficient, but it's not conditioning the power, particularly on the frequency side, then we're potentially leaving ourselves open to problems on the IT side. So let's consider the consequences of some of these choices we're making in search of improved energy efficiency and sustainability. Very laudable to have those goals, but let's consider what the actual purpose of a data center is. And again, it's all about keeping that service availability going. The one thing I would say, though, and I think this is a massive risk, is that regulation, legislation, and even potentially taxation are looming on the horizon. It is coming. We are perceived to be an energy hungry sector. And to some degree, that's true. I think some of the numbers have actually been inflated. Some of the numbers you see are not really based on reliable information, but nonetheless, we do consume a significant amount of power. And I think there's an increasing appetite for governments around the world to both legislate, regulate, and potentially tax. So that is coming, and that is a risk, I think, to many businesses. The only thing I would say on that is, yes, we do consume a significant amount of energy, but I think data centers and the services they offer will absolutely be part of the solution, rather than necessarily part of the problem. If we can't solve the climate change problem unless we have the resources based in data centers. So while we might be targeted as part of the problem, I think we're actually a very, very significant part of the solution. And finally, on this particular section, understanding your exposure to risk is vital. You can see the guy on the right kind of smiling because he's fished up quite a lot of cable. He's obviously very happy with himself. That auger has wrapped some considerable amount of cable. Now, what that cable was supplying, and the problems it's caused, I don't know, but some of it looks very much like fiber optic, and probably less power and more fiber. So probably some pretty significant challenges in there for a few people. So who's doing what around you, and what risks do you actually face? Potentially quite a concern. So look out for the risks all around you is what I'd say on that one. I'm going to run through this section very quickly. This is really how you might be able to mitigate some of the risks that you actually face. That picture on the right is actually a picture I took. Some guys inside an operational data center brazing a piece of pipe work for a cooling unit. But they do have a handy bucket of water on the floor to be able to quench the brazing, the work that they've done when it's hot. So I'll let you make your own judgments as whether that was a good thing. The picture on the left is the potential result of that, I think. So again, would it happen in your site, I guess, is the question. We've talked about the criticality. The one thing I would highlight in here is remember that the failure in any data center can cause loss of customers, loss of revenue, and loss of reputation. This is why it's important, and this is why it's difficult. But I think, I would expect most people on this call to actually understand that. So what's different? Well, I think the bottom line really, I think, is the most important thing here. It's not just about fixing problems in data centers. It's all about seeing what risks we face and being proactive in highlighting the issues, making sure that we are taking preventative actions, and making sure that we continue looking to improve or support the critical infrastructure and understanding and mitigating the risks. Keeping an active risk register and a wide-ranging risk register is absolutely crucial to this. Keeping it up to date and making sure that it's actually available and understood by everybody, absolutely essential. And without that, it's a very, very difficult to get started on protecting the availability of the services within data centers. Some expected behaviors, and again, you can read through this for yourselves, but the reality here is it's all about being proactive. It's all about recognizing the risks. It's all about reflection and introspection, looking at yourselves, looking at the environment that you're operating in, looking beyond that environment. Who's drilling outside, who's putting an auger into the ground that's going to rip up your fiber cables, etc. It's very much around that, being open-minded to potential threats and risks, and then doing something about it. It's not just enough to kind of look at a problem and then walk by and ignore it. It's actually got to go much further than that. It's got to go further and actually deal with those risks, or at least highlight them to people. Why do incidents happen? I think this is an interesting, again, piece of work from a guy called James Reason, who's a professor at Manchester University back in the 90s. And he was doing research on failures in healthcare, basically surgical failures. Why do things go wrong when, in those sort of critical situations? And his reason, no pun intended, that he came up with was that we think our defenses are impermeable. We think our defenses are absolutely solid. We've got solid walls, nothing can get through them. But the reality is they're more like what he calls Swiss cheese. We have lots and lots of holes. And unfortunately, when those holes line up, then things happen. Most of the time they don't line up. Most of the time they don't happen. But the point he's making is that we are not perfect. Those barriers we have in place are not perfect. And you've got to understand that they're not perfect. You've got to look for those holes. You've got to make sure that A, you recognize the holes, and then B, make sure they don't line up. So I think it's an interesting philosophy, an interesting way of looking at it. And I think if you take that mentality and if you think about how it works and what it means for your day-to-day operations, then actually you're going to understand how to mitigate risks. So again, an interesting piece of work that came from the medical industry. Plug the gaps, fill those holes. A lot of these things, you're going to be familiar with, you're going to be aware of. You can read this for yourself. These are all really responsibilities and tasks that I think any useful critical infrastructure management team should be taken to heart. These are all things that we should all be doing on a routine basis. We should be doing proper change control. We should be doing proper permitting. We should have proper method statements and sequence of operation. We should have proper documentation. We should have routine review of all those documents, all those procedures. This is all stuff we should be doing. And I'll let you read this. I'm not going to go through this in any great detail because, again, you can read it and just determine for yourself whether you're doing it or whether you should be introducing it. A comical slide, but there's some truth in it. Humans tend to do what you inspect and not what you expect. So you can take your most expensive, pristine Ferrari, give it to a monkey, and there's only going to be one result. So again, all about the importance of humans, all about human training, experience, motivation. Make sure you've got the right people looking after your Ferrari, basically. Risk management strategy flow chart. Well, again, this is a very simplistic way of looking at things, but start with the description or definition, and in this case, I would suggest go back to the business. What do we want to achieve as a business? And then take it from there. The data center is part of the mitigation process for business risk. It's not the only one, there are others, but start with the business, don't start with the engineering. And these next two or three slides, I think, many of you will be very aware of this. I'm not going to go through it in any great detail because I'm kind of teaching people to suck eggs in a way, but if you're not familiar with this, if you're from part of the business that doesn't necessarily, isn't necessarily familiar with this, generally the way we define, potential risk or potential impact, we determine that there's high, medium, and low. Okay, you can read that for yourselves, and that's fairly straightforward. But then what do we do with that? Then we tend to put it in some sort of, what we tend to do is put it in some sort of matrix. We say we've got high, medium, low impact, and then what's the likelihood of that occurring? Is it going to happen, or is it unlikely or improbable to happen? So from that, we start to look at working out some sort of matrix to determine what kind of risks we face, how impactful they may be, and how likely they are to happen. And from that, we can take the appropriate responses and mitigation methods. So once we've determined how often things might happen and how impactful they might be, then we can put it in some sort of matrix and work out from that where we're actually going to help us assess the level of risk that we're facing, and again, determine what the appropriate responses may be. Again, this is something that should be fairly familiar to most of you. If you're not familiar with this and it's new to you, then either come back to myself or the guys at Upsite, and they can explain that in very much more detail than I have time for here. So a risk management strategy, identify the risks, analyze the risks, rank the risk by probability and impact, as we've just discussed in the previous 3 slides, develop a plan, make sure that you've got an active risk register, make sure that your risk mitigation is based on active known risks, and that is routinely updated. And again, the final point here is risk assessment absolutely is a continual process. It's not something that ever stops. It's always work in progress, and it'll change. It'll change by season. It could be snowing one minute in obviously in the winter, and then 6 months later we're facing drought and potential subsidence because the water table's dropped. So there's all sorts of things that could be going on. So as we come to the end of the presentation, just improve your chances of success. If you are sitting under a large rock, at least be aware you're sitting under that large rock, and don't prop it up with pieces of potentially rotten wood. It's probably not going to work. If the process is, though, to prop the large rock up with a rotten piece of wood, then actually you do need to stand up and challenge the process and be seen to be heard. Make sure that if something it doesn't make sense or it doesn't seem logical, then challenge it. Make sure you question it, because in many cases, those challenges are appropriate. Doesn't mean you shouldn't do it. It doesn't mean that you should do, just blindly follow, but do challenge it. Operations are never static; they move on. We all have to keep moving things forward. It's really important that we don't remain static, because situations change. So again, by all means, absolutely 100% follow procedure. But if that procedure, that process doesn't appear correct, then challenge it, stop, ask the question. Absolutely crucial. And finally, really the things to avoid, which is kind of the summary of the whole presentation, is don't just rely on SLAs for service resilience. They're not ultimately going to protect you. They'll keep the legal guys happy, and they'll give you an operating, an understanding of how to operate and how to manage systems, but they're not going to protect you in any way. Manage the business critical space. Don't manage critical spaces the same way that you would do an office space or something. Critical spaces, data centers are different from offices. We all know that, but not everybody that employs us knows that. So be careful. Don't just rely on tools or technology to make the site reliable, the site more reliable. The right people with the right training and experience are far more important. Do keep the business objectives in mind, because the business objectives are what are going to actually keep guiding you towards understanding risk. Don't have PUE improvements linked to your bonus. I could go on for hours on that, but you might actually find that PUE is more complicated than people realize. And I think that's one of the lines in previous parts of the demonstrations. Not everybody understands metrics, and PUE I think is actually one of the less poorly understood metrics by many people. If it helps, it's defined by ISO IEC 30134-2. Anything else is not PUE. So just bear that in mind. Don't focus on green or energy efficiency because that can have a detrimental effect on reliability if you're not careful. Certainly don't perpetuate the IT and facilities divide, because that prevents good communication. That really won't help anybody. That poor communication does, in many cases, lead to not just misunderstanding, but a real introduction of risk. And don't hide from the difficulty of predicting IT requirements over time. And what I mean by that is, capacity planning on the IT side tends to be fairly poor. It certainly contributes to a lack of energy efficiency in many cases, classic over provisioning of cooling and power potentially, and that cooling and power never actually being used by the projected IT side, particularly as IT footprints are, tend to be shrinking. So that can be an issue, but I don't think it shouldn't be allowed to be an excuse for poor efficiency or the introduction of risk by not predicting IT requirements. And I think the final message, I think, really from me is that you can't outsource risk. It's impossible to outsource risk. Whatever anybody says to you, you cannot outsource risk. You can outsource the management of risk, but the risk remains with you. You can get someone else to manage it, you can get someone else to mitigate it for you, but the risk remains with you. And that again goes back to the contract and SLA piece. You cannot basically avoid risk. You can't push risk away just by having someone else take responsibility through contract or SLA. It just doesn't work. And that probably is my final message. Thank you. Over to questions. We have about 5 minutes, I believe.
All right, thank you, Mark. Tons of great information. We have gotten a couple of requests for a recording to this presentation, and the answer is yes. We will send out the recording as well as the slide deck within the next couple of days. And with that, we have a few minutes for a couple questions, so let's jump right into them. Mark, this one's a little bit of a longer question, or a two-pronged question. If Tier 3 allows for concurrent maintenance, doesn't that mean I also have redundancy while maintenance is not being performed? I.e., could I not lose a cooling pump, a transformer, etc., and maintain operations? If I can take it down for maintenance, surely I can lose it unplanned.
Potentially, yes. So, let's say, for instance, you're quite right. So for concurrent maintainability, yes, you're clearly going to need more than one of the thing that you're maintaining, certainly. If you're planning that maintenance, though, you can predict what's going to happen if that piece of equipment fails. If it fails, though, in a catastrophic manner, let's say it's a pump and the pump goes, the seals go on the pump, and there is no valve to shut that chill water supply off, could that entire chill water supply, flood out, you lose the cooling. So it's, in theory, you're right. Yes, it should leave you, if you have a Tier 3 site, it should leave you with some, degree of additional capability, additional systems, but you've got to think about the failure mode. What's happened? What's gone wrong? Why has it gone wrong? If it's just a piece of equipment, failing in a very benign manner, then yes, you're probably all right. But there is no guarantee of that. And that's the point about Tier 4. You've got essentially completely separate systems. If one entire system's taken out, then the other system merely takes over. There's no connection between those systems. There's no dependency whatsoever. In Tier 3, you can have dependencies between the systems. Remember, Tier 3 is not automatically switched from one side to another. It can, in many cases, rely on manual switching. So again, if there's nobody there to do that switching, or they don't understand it, or they're not capable, then, again, you get back into this failure. So it depends on the failure mode. In theory, yes, but I wouldn't rely on it. That would be my answer.
Great. Thank you, Mark. Next question. Can reduction of UPS backup time for 15 minutes affect the system? What kind of risks associate if reduction of backup time?
That's a really interesting question. I'm going to pose the question back, and it's slightly rhetorical. Why do we have 15 or 20 minutes battery autonomy anyway? Well, originally it was designed so that we could safely quiesce IT equipment. We gave ourselves that period of time to basically shut things down. Well, obviously in a large modern data center, that's never going to happen. A, you're never going to get permission, and B, you just wouldn't get the time to do it. So I think the reason for that 15 to 20 minutes autonomy is somewhat historic, and I don't know that it actually has any basis in fact these days. The reality is, how much autonomy do you need in a data center system that's got proper generator support? Your generators are going to start taking load, let's say within about 5 to 10 seconds. If you're doing it properly. If they haven't taken load within that 5 or 10 seconds, then you may have the opportunity to do something around it. But I would suggest that if you haven't got the system started within, let's say, 5 minutes, you're probably not going to get them started, or you're not going to be able to switch around the problem. Does 15 or 20 minutes make much difference? Probably not in reality. The only thing I would say is that depending on how you're staffing your data centers, what you do need to do is give your operatives a chance to actually do something, or at least respond to the situation. If you've got a very large data center, and let's say they're 100 meters away from the scene of the failure, or the place they need to be to do something, then you've got to give them time to get there. So I would suggest that your battery autonomy should really be more dependent on what the guys on the ground can actually achieve in terms of being physically present during the period of that incident. The original 15 to 20 minutes though that we worked to, I think that is lost in the history, the mists of history. I don't think there's any real reason for having 15, 20 minutes or anything else. So I would think your battery autonomy is absolutely based on what your operational processes are, what your staffing model is, and what you think you can do in the time available.
Great, thank you, Mark. I think we got time for one more question. How can businesses ensure they are protected if SLAs are not transparent or effective when it comes to managing risks?
Yeah, really good question. I think businesses need to fully understand the services that are being supplied to them. I think again the one area where I think we are introducing the most risk is in the provision of cloud services. People are buying cloud services without necessarily understanding what's underpinning those cloud services and the infrastructure that those services are actually dependent on. And I think this is particularly true when you look at some of the smaller MSPs that are in data centers that were probably built at the early part of this century, late 1990s even. They may not have gone through lifecycle refreshers. They may be based on equipment that may or may not be as reliable as it should be. And I think we're seeing a disconnect between those supplying and buying cloud services and those that are providing the infrastructure on which they're dependent. They're hidden, very, very hidden. So as a business, I would always advise that they get in a consultant who understands the underlying risks that are being faced by a cloud provider. So don't just look at what the cloud provider is offering in the way of SLA. Look at the SLAs and the way that their suppliers are supplying to them. Are the contracts and SLAs that are in place underneath the cloud provider in line? Can they actually support the requirements of the cloud provider and down and down and down beyond? So I would always get an engineering consultant, someone, a genuine expert in data centers, to have a look and say, okay, the cloud provider's SLAs seem to match your business requirements, but what about the people who are supporting them? What about the businesses that are supporting them? That's you've got to look down. You've got to use the microscope and go further down the tree to understand what's really happening. That I would suggest is the best way to protect yourself. Great,
thank you, Mark. Unfortunately, that is all the time we have. If we didn't get to your question, we will follow up with you after to get that answered for you. I'd like to thank everybody for joining us here today. And Mark, special thank you to you. It is always a pleasure having you speak for our Airflow Management Awareness Month. Great presentation, very informative, and thank you very much for joining us here today.
Thank you, Isaac. Thanks, Uptime, and thanks everybody for joining. I hope you got some useful information.